Okay, here's number 7 and 8 from that old final exam that I posted. So number 7, graph solutions to 4x minus 2y greater than negative 6. So an inequality like this is easiest to graph if we put it into slope-intercept form first. So let's do that by solving this inequality for y. So we'll subtract 4x from both sides. We get negative 2y is greater than negative 4x minus 6. Okay, now we can divide both sides by negative 2. On the left we get y. On the right, negative 4x over negative 2 is positive 2x. And negative 6 over negative 2 is positive 3, like this. And because we divided this inequality by a negative number, this inequality symbol turns around, so like this. All right, so now we can go ahead and treat this like a line and graph the line. So this looks like the line y equals 2x plus 3. All right, and to graph this, our y-intercept is 3, so we'll start there. And this slope, 2, if we try to go over 1 and up 2, we're going to be off the graph. But remember, we can, instead of going over 1 and up 2, we can interpret this 2 as negative 2 over negative 1, so we can go left 1 and down 2. So left 1 and down 2, that's going to be here. So the boundary line between the two halves of the plane that we want for this inequality will be the line between these 2 points. Because this inequality is a strict inequality, since it's not or equal to, the line itself will not be included in the solutions. So we'll use a dotted line to indicate that this line itself is separating the two half planes, but it is not itself making up solutions. All right, now we need to decide which side of the line do we want, the stuff above or the stuff below. This inequality says that y, which is a height, should be less than the line, which is 2x plus 3. So the height is less than the line. That's the stuff below the line. So this side of the line is solutions to the inequality. All right, so there's our graph. Let's have a look at number 8. Here it is. Solve this system using substitution. All right, so you can tell that you can tell substitution is a good idea because one of our equations, this one, is already solved for one of the variables. So we can take this equation. This equation tells us that y is minus 2x minus 4. So we can take minus 2x minus 4 and just put it into the first equation for y. All right, so when we do that, we get 3x minus 5 times y, but remember y is minus 2x minus 4, okay, equals negative 19. Now we have an equation with only one variable, so we can go ahead and solve this equation for x. To do that, we're going to start by distributing this negative 5 here, so 3x minus 5 times negative 2 is positive 10, so plus 10x. Okay, and then negative 5 times negative 4 is plus 20 equals negative 19. Okay, now we can simplify the left-hand side. 13x plus 20 equals negative 19. Now we can get the 20 to the other side, subtract 20 from both sides. We get 13x equals negative 39. Divide both sides by 13. I'm just going to make it x equals 3. I'm sorry, negative 3. All right, so now we know x is negative 3. We still need to find y. Remember, a solution to a system of equations like this is a value for x and for y. We know what x is, but we need to go back and find y. So we'll take our second equation from this system here, this equation, together with the value of x that we already know. So this equation says that y is negative 2x minus 4. We know what x is. It's negative 3, so we'll put that in there for x. Whoops, I forgot my 2 over here. Okay, so y is negative 2 times x, which is negative 3, minus 4. And now we can just do this arithmetic. Negative 2 times negative 3 is 6, minus 4, that's 2. So our solution, which is x comma y, is the point negative 3 comma 2. All right. So tomorrow I'll get through maybe 4 more problems. We'll see how far I get. Bye.